You are listening to Ethereum Explained, unlocking the power of smart contracts. Subscribe to keep up to date on our latest audiobooks. Ethereum Explained, unlocking the power of smart contracts. Welcome to the revolution. What are smart contracts? Imagine trying to buy a house. You typically need lawyers, banks, notaries, and real estate agents. There's paperwork, waiting periods, and a lot of money exchanged. Crucially, you're placing trust in several intermediaries to ensure everyone plays by the rules and the deal goes through as agreed. The process can be opaque, expensive, and time-consuming. What if there was a way to make this process smoother, faster, and built on verifiable certainty rather than just human trust? Enter smart contracts. Think of them not as complex legal documents filled with legalese, but as digital vending machines for agreements. You put in your coins or digital asset, make your selection, and out comes your desired item instantly and reliably. There's no need to trust a human attendant or worry if the machine will glitch. The machine's programming ensures the designated item is dispensed only if the payment is correct. If the payment is insufficient, the machine simply won't release the item. The rules are clear, immutable, and enforced automatically. This simple analogy captures the essence of a smart contract: self-executing, tamper-proof, and designed to automate outcomes based on predefined conditions. They eliminate the need for intermediaries because the rules are embedded directly into code that runs on a decentralized network. They offer the promise of automation that eradicates human error, eliminates the need for expensive third parties, and creates a new bedrock of trust rooted in mathematics and transparent code, rather than promises or institutions. Smart contracts, a historical glimpse. While they sound futuristic, the idea of smart contracts isn't new. The concept was first introduced in the mid-1990s by a visionary computer scientist named Nick Szabo. Long before Bitcoin or Ethereum existed, Szabo envisioned digital protocols that could execute contract clauses automatically. He saw a future where legal agreements could be embedded in hardware and software, making them self-enforcing. Szabo used a very tangible example: the possibility of a smart property machine that could transfer ownership of a car title only when the correct payment was received, without needing a department of motor vehicles in between. Or imagine a vending machine-like process for buying medical insurance, where payment automatically delivered a policy, and an accident report automatically triggered a payout according to a clear set of rules. His ideas were remarkably prophetic, but the technology to make them truly viable, a secure, decentralized, and globally accessible network, didn't exist yet. The advent of blockchain technology provided the missing piece, turning Szabo's dream into a tangible reality by offering a trustworthy, shared ledger upon which these smart agreements could operate. More than just code. The agreement in smart contracts. At their core, smart contracts are simply lines of code, but they are special lines of code. They are stored and executed on a blockchain, which gives them unique and powerful properties. Self-executing. Once the conditions written into the code are met, the contract automatically executes the agreed-upon actions. No one needs to press a button, give approval, or chase up a payment. It simply happens. Tamper-proof, immutable. Once deployed onto the blockchain, a smart contract's code cannot be changed. This means the rules are set in stone and cannot be altered by any single party or even a group without consensus. This is a powerful feature, guaranteeing the agreement's integrity, but it also highlights the critical importance of writing bug-free code from the outset. Transparent. The code of most smart contracts is publicly viewable on the blockchain. Anyone can inspect the rules governing the contract, fostering trust through verifiable transparency, not just blind faith. This openness means that the underlying logic can be audited and scrutinized by anyone. You don't have to trust that the contract will do what it says. You can verify it. Deterministic. Given the same set of inputs, a smart contract will always produce the same output. There's no ambiguity, no human interpretation, and no room for subjective judgment. It's a pure if this, then that logic. If condition X is true, then action Y will always occur. This deterministic nature is why proponents often say code is law in the context of smart contracts. The code itself dictates the outcome, removing human discretion, bias, and the potential for error that can plague traditional, human-mediated agreements. Why smart? It's important to clarify that smart in smart contract doesn't mean intelligent in the way artificial intelligence is smart. These contracts don't learn, intuit, or make subjective decisions. They are complex programs, but they are not conscious or thinking. They are smart because they automate the execution of agreements and mediate interactions with unprecedented precision and without human intervention, ensuring that the agreed-upon terms are strictly adhered to. They are efficient, reliable, and reduce the need for costly intermediaries. Where traditional contracts rely on the legal system for enforcement, smart contracts enforce themselves through cryptographic security and network consensus. They replace the slow, manual, and often costly processes of traditional agreements with instantaneous, automated, and provably fair execution. A glimpse into the future. The implications of smart contracts extend far beyond simple vending machine transactions. They are the foundational technology for an explosion of innovation across various sectors, creating entirely new paradigms for how we interact, transact, and organize. Finance, DeFi, enabling peer-to-peer lending, borrowing, trading, and insurance without traditional banks or financial institutions. Ownership, NFTs, creating unique, verifiable digital ownership for art, collectibles, music, and even fractions of real-world assets. Organizations, DAOs, allowing groups to govern themselves transparently and collectively, distributing power and decision-making far beyond traditional hierarchical structures. Supply chains, tracking goods, ensuring authenticity, and automating payments as products move through complex global networks. Identity management, empowering individuals to own and control their digital identities, granting access to only necessary information. The potential for smart contracts to revolutionize industries and empower individuals is immense. In the coming chapters, we will unravel how this digital vending machine concept, powered by the Ethereum blockchain, is fundamentally reshaping industries and preparing us for a new era of digital trust. But first, to truly grasp the reach of smart contracts, we must understand the revolutionary platform that makes all this possible, Ethereum. The foundation, Ethereum and the blockchain explained. To understand smart contracts, we must first grasp their foundational technology, the blockchain. And to understand smart contracts in their most prolific form, we must understand the specific blockchain that powers most of them. Ethereum. Back to basics. What is a blockchain? Imagine a vast, perpetually growing digital ledger. This ledger isn't kept in one central location, like a bank's database, but is simultaneously maintained and updated by thousands of computers around the world. Every entry on this ledger is grouped into blocks, and each new block is cryptographically linked to the previous one, forming an unbroken chain. This is the essence of a blockchain. Think of it like a community-maintained global spreadsheet, but with some crucial differences. Distributed and decentralized. There's no central authority controlling the spreadsheet. Instead, copies are held by countless participants. This makes it incredibly resilient. If one computer goes offline, the others continue to operate seamlessly. Immutable. Once a transaction is recorded and confirmed within a block, it cannot be altered or deleted. It's etched into the digital stone of the blockchain forever. This provides an unprecedented level of security and auditability. Transparent, but pseudonymous, every transaction and every piece of data recorded on the public blockchain is visible to anyone. You can see what happened when it happened and between which addresses. However, you don't necessarily know the real-world identity behind those addresses, ensuring a degree of privacy. Trustless. Because of its decentralized, immutable, and transparent nature, participants don't need to trust a third party. They trust the underlying technology and the network's consensus mechanisms. The system is designed to remove the need for human trust by replacing it with mathematical verification. This trustless nature is the blockchain's most profound contribution. It allows people who don't know or trust each other to agree on a shared record of truth. Bitcoin versus Ethereum, a tale of two blockchains. The world's first widely successful blockchain was Bitcoin, introduced in 2009 by the anonymous Satoshi Nakamoto. Bitcoin famously created the first truly decentralized digital currency. Its primary function is to serve as a peer-to-peer electronic cash system, essentially, a highly secure and transparent way to send and receive value without intermediaries. Bitcoin was revolutionary, but it was designed for a specific purpose. If Bitcoin is like a calculator, designed efficiently for a single, powerful function, sending money, Ethereum is like a smartphone. Ethereum, launched in 2015 by Vitalik Buterin and a team of co-founders, took the underlying blockchain concept and expanded its potential dramatically. Instead of just being a ledger for currency, Ethereum was designed to be a programmable platform, a world computer. This means developers can build and deploy all sorts of decentralized applications, dApps, and most importantly for our discussion, smart contracts, directly onto the Ethereum blockchain. While Bitcoin processes transactions for its native currency, BTC, Ethereum processes transactions for its native currency, Ether, ETH, but also serves as the operating system for countless other digital assets and programs. ETH is used not only as a store of value, but also as the gas or fuel to power transactions and execute smart contracts on the network. The Ethereum Virtual Machine, EVM, the heart of the world computer. If Ethereum is the smartphone, then the Ethereum Virtual Machine, or EVM, is its operating system. The EVM is a powerful, decentralized computing environment that lives on the computers of every participant in the Ethereum network. It is precisely what allows smart contracts to run on Ethereum. When a smart contract is deployed on Ethereum, its code is sent to the EVM. The EVM then executes this code, processing transactions, managing contract states, and ensuring that every participant's copy of the blockchain stays in sync. Because every computer running the EVM processes the exact same instructions in the exact same way, the outcomes of smart contract executions are guaranteed to be consistent across the entire decentralized network. This uniformity is critical for the code is law principle of smart contracts. The EVM is what makes Ethereum so much more than just a cryptocurrency. It's a global, shared computational engine, a single, logical computer accessible to anyone globally, anytime, for executing arbitrary code. Transactions, gas, and validators. Powering the network. Every action you take on the Ethereum network, sending ETH, interacting with a smart contract, or deploying a new one, is a transaction. Each transaction requires computational effort from the network's participants. To compensate these participants and prevent the network from being flooded with spam, every transaction incurs a fee called gas. Think of gas like the fuel you put in your car. Just as you pay money for gasoline to make your car run, you pay a gas fee in ETH to make your transaction run on the Ethereum network. The more complex an operation, like executing a sophisticated smart contract, the more gas it consumes. The price of gas fluctuates based on network demand. When the network is busy, gas prices go up. Historically, the Ethereum network was secured and transactions were processed by miners, much like Bitcoin's proof-of-work system. However, in a monumental upgrade completed in September 2022 known as the merge, Ethereum transitioned from proof-of-work, POW, to proof-of-stake, POS. Under POS, instead of competing to solve complex puzzles, which consumes a lot of electricity, network participants called validators stake or lock up their ETH as collateral. These validators are then randomly chosen to propose and validate new blocks of transactions. If they act honestly, they earn rewards. If they act maliciously, they can lose their staked ETH. This change made Ethereum significantly more energy efficient and set the stage for future upgrades aimed at increasing its scalability. Wallets and addresses. Your gateway to Ethereum. To interact with the Ethereum blockchain, whether to send ETH, receive assets, or use a decentralized application, you'll need a digital wallet. This isn't a physical wallet, but rather a software application or a hardware device that manages your cryptographic keys. Every wallet has a unique public address, which is like your bank account number. You can share this address with anyone to receive funds or assets, but the true power and security of your wallet lie in its private key. This is a secret, alphanumeric code that acts like your signature or password. Whoever controls the private key controls the assets associated with that public address. This is why the phrase, "not your keys, not your crypto," is paramount in the blockchain world. Unlike a traditional bank account where the bank holds your funds and can recover your password, losing your private key or having it stolen means permanently losing access to your funds. Conversely, as long as you secure your private key, you have complete and total control over your digital assets, entirely independent of banks or other institutions. With this foundational understanding of blockchain technology and Ethereum as its leading programmable platform, we are now ready to delve into the inner workings of smart contracts themselves, exploring how these digital agreements are built and how they truly operate on this decentralized world computer. Anatomy of a smart contract. How they really work. We've established that smart contracts are self-executing agreements living on the blockchain. But how do these digital vending machines actually function? What are they made of? In this chapter, we'll open up the hood, so to speak, and explore the anatomy of a smart contract without getting lost in the weeds of technical coding. Code, not law yet. What smart contracts are made of? At its simplest, a smart contract is a computer program. But unlike traditional programs on your laptop, these programs are designed to run on the decentralized, global computer that is the Ethereum Virtual Machine, EVM. They are written in specialized programming languages. For Ethereum, the most popular language is Solidity, though others like Viper also exist. Imagine a highly precise recipe or a set of instructions that a robotic chef can follow perfectly every single time. That's similar to a smart contract. The developer writes these instructions in Solidity, detailing exactly what the contract should do under various conditions. For example, if Alice sends 1 ETH to this contract, then send 0.5 ETH back to her and 0.5 ETH to Bob. If the temperature here exceeds 30 degrees Celsius, then trigger a payment of 100 USD to a specific address. When 100 people have each deposited 0.1 ETH, randomly select one of them and send all 10 ETH to their address. Once these human-readable instructions, the source code, are complete, they must be translated into a language the EVM can understand. This process is called compiling. The Solidity code is compiled into bytecode, which is essentially the machine language that the EVM executes. This bytecode is then deployed to the Ethereum blockchain. Life cycle of a smart contract. A smart contract typically goes through a few key stages. Development. A programmer writes the contract's code, defining its functions and logic. This stage involves meticulous testing, as bugs in smart contracts can have severe, irreversible consequences once deployed. Deployment. Once ready, the compiled bytecode of the smart contract is published onto the Ethereum blockchain. This is a transaction like any other, and it costs gas. Once deployed, the contract receives its own unique address on the blockchain, just like a user's wallet address. Crucially, at this point, the contract becomes immutable. Its code cannot be altered, removed, or stopped by the deployer or anyone else. This immutability is central to the trustlessness of smart contracts, but it also means that any bugs or vulnerabilities become permanent. Execution interaction. After deployment, the smart contract sits on the blockchain dormant until an external transaction calls one of its functions. For example, a user might send Ether to its address or call a specific function like vote or buy an NFT through a decentralized application, DApp. When a function is called, the EVM executes the contract's code, performs the specified actions, updates its internal state, if any, and records the outcome on the blockchain. Functions and state. The building blocks. To understand how a smart contract operates, it's helpful to think of two main components. Functions. These are the actions a contract can perform. They are like the buttons on our vending machine example. Each function is a piece of code designed to do something specific. For instance, in a simple lottery smart contract, you might have functions like enter lottery, allows a user to join the lottery by sending a specific amount of ETH. Pick winner selects a winner randomly after certain conditions are met, like enough participants. Withdraw winnings enables the winner to claim the prize. State variables, these are the memory of the smart contract. They store information that the contract needs to keep track of. In our lottery example, the state variables might include participant list, a list of all addresses that have entered the lottery. Prize pool, the total amount of ETH accumulated for the prize. Owner, the address of the person who deployed the contract, potentially. Many contracts aim for decentralized ownership. When a function is called, it might read from these state variables, perform calculations, and then update them. For example, when enter lottery is called, it adds the user's address to participant list and increases prize pool. When pick winner is called, it identifies the winner and withdraw winnings, might then reduce prize pool once the winner claims their prize. Oracles, connecting the real world to the blockchain. Blockchains are incredibly secure and deterministic, but they are also isolated. They cannot, by themselves, access information from the outside world. A smart contract on Ethereum doesn't inherently know what the current price of Bitcoin is, or the weather in Tokyo, or the outcome of a sports match. This is known as the oracle problem. This is where oracles come in. Oracles are third-party services that feed external, real-world data into smart contracts in a trust-minimized way. They act as bridges between the off-chain world and the on-chain world. For example, imagine a smart contract for an insurance policy that pays out if a specific flight is delayed by more than 2 hours. The contract itself can't check flight status. It needs an oracle to provide that information. The oracle would fetch the flight data, e.g., from an airline's API, and then securely submit it to the smart contract. Once the contract receives this reliable data, it can then automatically execute the payout function if the conditions are met. The challenge with oracles is ensuring the data they provide is accurate and decentralized. If a smart contract relies on a single, centralized oracle, that oracle becomes a single point of failure and potential manipulation. Therefore, decentralized oracle networks, like Chainlink, a popular oracle solution, are designed to aggregate data from multiple sources and ensure its integrity. Events and dApps, interacting with smart contracts. How do users actually interact with these complex pieces of code? And how do applications outside the blockchain know what a smart contract is doing? Events. Smart contracts can emit events, essentially, logging specific actions or changes that occur within the contract. These events are lightweight and are stored on the blockchain, but they don't consume as much gas as directly storing data in state variables. External applications can listen for these events. For instance, if you buy an NFT, the smart contract might emit an ownership-transferred event, letting any interested application know that a new owner has been recorded for that specific token. This is how decentralized exchanges, wallets, and user interfaces display real-time updates without having to constantly query the entire blockchain state. dApps, decentralized applications. A dApp is a regular web or mobile application that connects to and interacts with smart contracts on a blockchain. Think of them as the user-friendly interface that allows you to easily execute the functions of a smart contract without needing to write code yourself. If the smart contract is the engine and mechanics of our vending machine, the dApp is the sleek user interface with the buttons and screen that you tap to make your selection. When you use a dApp like a DeFi lending platform or an NFT marketplace, you're not directly interacting with the complex code of the smart contract. Instead, the dApp translates your clicks and inputs into transactions that call the specific functions of the underlying smart contracts. Your crypto wallet, like MetaMask, then signs these transactions, and they are sent to the Ethereum blockchain for execution by the EVM. With a firm grasp of how smart contracts operate at this conceptual level, we can now dive into their revolutionary applications. Over the next few chapters, we'll explore how these automated, transparent agreements are disrupting industries, from finance to art, and even reimagining how organizations can be managed. DeFi demystified. Smart contracts powering financial innovation. Imagine a financial system that operates 24/7, globally, with minimal fees, no lengthy approval processes, and without the need for traditional banks, brokers, or clearinghouses. This is the promise of decentralized finance, or DeFi. Built primarily on smart contracts on the Ethereum blockchain, DeFi is an open, permissionless, and transparent ecosystem of financial applications. For centuries, finance has relied on intermediaries. If you wanted a loan, you went to a bank. If you wanted to trade stocks, you used a broker. These intermediaries manage risk, provide security, hopefully, and ensure transactions are settled. However, they also add costs, introduce delays, maintain opacity, and can even act as gatekeepers, excluding certain individuals or entities. DeFi seeks to disintermediate these processes. It leverages smart contracts to automate crucial financial services like lending, borrowing, trading, and asset management, replacing human gatekeepers and opaque institutions with immutable code. This system is often referred to as money Legos because its various protocols, each a set of smart contracts, can be stacked and combined in innovative ways to create new and more complex financial products, much like building with actual Lego bricks. Lending and borrowing, of and compound. In traditional finance, getting a loan involves credit checks, extensive paperwork, and potentially weeks of waiting for approval. In DeFi, smart contracts enable peer-to-peer, or rather, pool-to-peer, lending and borrowing that is instantaneous and transparent. Protocols like OV and Compound are prime examples of how this works. How it works. Instead of borrowing from a bank, you interact with a smart contract. Lenders provide their cryptocurrencies, e.g., Ether, stablecoins like USDC, to a shared liquidity pool managed by the smart contract. Borrowers can then draw from this pool, provided they supply sufficient collateral, usually in the form of other cryptocurrencies. Collateralization. Most DeFi loans are over-collateralized. This means a borrower must put up more value in crypto than they wish to borrow, e.g., provide $150 worth of Ether to borrow $100 worth of stablecoins. This over-collateralization is essential for protecting the lenders in a volatile market and replaces the need for a credit score. Automated management. The smart contract automatically manages the entire loan lifecycle, calculating interest rates algorithmically, often based on supply and demand within the pool, monitoring the collateral's value, and executing liquidations. If the value of the collateral backing a loan drops too low, the smart contract automatically liquidates, sells a portion of the collateral to repay the loan, protecting the lender. Case study, lending on OV. Imagine Alice has some Ether ETH she's not actively using but doesn't want to sell. She can deposit her ETH into OV's smart contract. OV pools her ETH with other lenders' ETH, creating a large pool of capital. Bob, a crypto trader, needs some stablecoins like USDC pegged to the US dollar for a short period to make a trade, but he doesn't want to sell his ETH. He can put up a larger amount of his own ETH as collateral on OV and instantly borrow USDC from the pool. Alice earns interest on her deposited ETH instantly, and Bob gets his USDC. The entire transaction is managed transparently by OV's smart contracts, without the need for any human intervention. No bank statements, no credit checks, just code executing agreements. Decentralized exchanges, DEXs. Uniswap and automated market makers, AMMs. How do you trade one cryptocurrency for another without a centralized exchange like Coinbase or Binance? Decentralized exchanges, DEXs, are the answer. Unlike centralized exchanges that hold your funds and match buyers and sellers with an order book, DEXs allow users to trade directly from their wallets, maintaining control over their assets every step of the way. Uniswap. A leading DEX on Ethereum, Uniswap revolutionized crypto trading with its automated market maker, AMM model. How AMMs work. Instead of relying on traditional order books, where buyers and sellers place specific price bids and asks, AMMs use liquidity pools. These pools are pairs of tokens, e.g., ETH and USDC, that users called liquidity providers contribute. When you want to trade ETH for USDC on Uniswap, you're not trading with another individual directly, but rather with this shared liquidity pool managed by Uniswap's smart contract. The price for the trade is determined by a pre-programmed algorithm based on the ratio of the tokens currently in the pool. Role of liquidity providers. Individuals who deposit their token pairs into these pools earn a share of the transaction fees generated by trades within that pool. This provides a powerful incentive for anyone to become a market maker and contribute to the liquidity of the decentralized financial system. Implication: this model makes it incredibly easy and permissionless for anyone to create a market for virtually any token, promoting broad access and innovation in the crypto ecosystem. Stablecoins, bridging volatility and stability. One of crypto's biggest challenges is its inherent volatility. How do you lend, borrow, save, or pay for goods if the value of your currency fluctuates dramatically from day to day or even hour to hour? Stablecoins are cryptocurrencies designed to maintain a stable value, usually pegged to a fiat currency like the US dollar, e.g., USD coin or Tether, or sometimes commodities like gold. They are crucial for DeFi because they provide a haven from market swings, allowing for more predictable financial activities. Types of stablecoins: fiat-backed, the most common type. For every stablecoin issued, an equivalent amount of fiat currency, e.g., USD, is held in a traditional bank account or reserves by a centralized entity. USDC and USDT are prime examples. The stability relies on the issuer's solvency and transparency. Crypto-backed, decentralized. Stablecoins like DAI are backed by other cryptocurrencies. They maintain their peg through smart contracts that manage collateralization and liquidation. For instance, to mint DAI, a user locks up a greater value of a crypto asset, like ETH or USDC, into a smart contract vault. If the collateral's value drops too low, the contract can automatically liquidate it to protect the peg. These are typically more transparent as their backing is on-chain. It's worth noting that other, more experimental types of stablecoins, such as algorithmic stablecoins, have also emerged. However, some, like the Terra Luna ecosystem, have experienced dramatic failures, highlighting the complexities and risks that can arise when the stability mechanisms are purely algorithmic and not backed by sufficient real-world or on-chain collateral. Stablecoins provide the necessary stability for a rapidly evolving DeFi ecosystem, allowing users to engage in lending, borrowing, and trading without constant exposure to the broader crypto market's daily price swings. Yield farming and staking, earning passive income with smart contracts. Smart contracts don't just facilitate financial services, they also enable users to earn passive income in innovative ways within the DeFi ecosystem. Yield farming. This is the practice of strategically moving cryptocurrencies between different DeFi protocols to maximize returns. It involves providing liquidity to DEXs, lending assets to lending protocols, or locking up tokens in other DeFi applications to earn fees, governance tokens, or a combination of rewards. The farm refers to the continuous effort to find the highest yield, return. Smart contracts are fundamental to this process, managing the distribution of these rewards and the terms of participation automatically. Staking. On Ethereum and other proof-of-stake blockchains, staking involves locking up your cryptocurrencies to help secure the network. By staking ETH, you commit your assets to the network's security and validation process, in return for performing the crucial work of validating transactions and proposing new blocks. Smart contracts automatically distribute rewards, often newly minted ETH or a share of transaction fees, to you. This passive income mechanism is a core component of Ethereum's post-MERJ operations and offers a greener, more energy-efficient alternative to the energy-intensive mining process of older blockchains like Bitcoin. The entire DeFi landscape is a testament to the power of smart contracts to redefine financial services, offering an open, transparent, and user-controlled alternative to traditional systems. However, this revolutionary new world is not without its challenges and risks, which we will explore later. But first, let's pivot from finance to the fascinating world of unique digital assets, also powered by smart contracts. Non-fungible tokens, art, collectibles, and beyond, the world of NFTs. We've seen how smart contracts are revolutionizing finance. Now, let's turn our attention to another groundbreaking application that has captured headlines and ignited cultural shifts: non-fungible tokens, or NFTs. At their core, NFTs use smart contracts to establish unique digital ownership, transforming everything from art and collectibles to gaming and identity. The concept of scarcity in the digital age. For most of history, scarcity was inherent in physical objects. A painting by Vincent van Gogh, a rare stamp, or a collector's edition comic book all derive value from their unique existence and limited supply. When it comes to digital items, however, this concept of scarcity breaks down. A digital image can be copied infinitely, perfectly, and at virtually no cost. How do you distinguish the original digital artwork from a million copies? How do you create genuine, verifiable ownership of something that exists only as data? Historically, proving ownership of digital assets has relied on centralized authorities. A gaming company owns your in-game items, a streaming service gives you access to music, but you don't truly own the MP3 file in a way that is unique and transferable. Copyright laws exist, but enforcing them across a global, fragmented internet is a monumental task. The true innovation of NFTs lies in solving this fundamental problem, bringing verifiable scarcity and unique ownership to the digital realm. What exactly is an NFT? Unpacking non-fungibility. To understand NFTs, we first need to understand the difference between fungible and non-fungible. Fungible, something is fungible if each unit is interchangeable and indistinguishable from another. For example, a dollar bill is fungible. $1 is identical in value and nature to any other dollar. If you lend someone $1, you don't care which specific dollar bill they return. Bitcoin and Ether are also fungible. One ETH is the same as any other ETH. Non-fungible. Something is non-fungible if it is unique and cannot be swapped for an identical item. Your passport, a specific house, or a one-of-a-kind painting are non-fungible. If you loan a friend your car, you expect to get that specific car back, not just any car of the same model. An NFT is a unique digital token that is recorded on a blockchain. This token represents ownership of a specific item, which can be digital, like a piece of art, a collectible, a song, or a virtual land plot, or increasingly linked to a physical item. Crucial clarification: an NFT is not the digital image or song file itself. It is a digital certificate of authenticity and ownership that points to that specific digital or physical asset. Think of it like this. Anyone can take a picture of the Mona Lisa, but only one entity owns the original painting at the Louvre. With NFTs, millions can write, click, and save an image, but only one wallet address publicly and verifiably owns the NFT, which is the unique digital title to that original. Smart contracts behind the NFT magic. The magic of NFTs lies entirely in the smart contracts that govern them. Instead of being generic programs, NFTs adhere to specific, widely accepted smart contract standards, with ERC 721 being the most common for unique NFTs on Ethereum. Another standard, ERC 1155, allows for both fungible and non-fungible tokens, offering more flexibility for things like gaming assets. When you mint an NFT, you're essentially deploying a smart contract, or interacting with an existing one, that creates a unique token, identified by a token ID, and assigns its ownership to your blockchain wallet address. This smart contract contains functions to mint new tokens, create new, unique NFTs, assign ownership, link a specific NFT to a particular wallet address, transfer ownership, allow NFTs to be securely bought, sold, and traded between different wallet addresses. Verify rarity and attributes. Store metadata that describes the characteristics of the NFT, which can be used to determine its rarity, e.g., in a collection of 10,000 profile pictures, some might have rarer traits than others. Enable royalties. This is one of the most revolutionary features. Smart contracts can be programmed to automatically pay the original creator a percentage of all future secondary sales of their NFT. This means artists and creators can earn passive income every time their work is resold, creating sustainable revenue streams that were virtually impossible in the traditional art world. Beyond art. Diverse applications of NFTs. While digital art and collectibles have dominated the headlines, the applications of NFTs extend far beyond JPEGs and profile pictures. Digital collectibles. Projects like CryptoPunks, Bored Ape Yacht Club, and countless others redefined digital status and community. They demonstrated the power of digital identity and the cultural significance of unique digital possessions. Gaming. NFTs are transforming the gaming industry by enabling true digital ownership. Players can now genuinely own their in-game items, characters, and even virtual land, as seen in metaverse games like Decentraland or The Sandbox. This means they can buy, sell, or trade these assets freely on open marketplaces, or even take them from one game to another if compatible. This creates entire player-owned economies. Ticketing. NFTs can act as tamper-proof event tickets, preventing counterfeiting and enabling transparent resales. Identity and credentials. Imagine your academic degrees, professional certifications, or even elements of your digital identity stored as NFTs in your wallet. You own and control these credentials, choosing exactly when and with whom to share them without relying on centralized databases. Physical asset tokenization. NFTs are increasingly being used to represent fractional or full ownership of physical assets, such as real estate, luxury goods, rare wines, or even carbon credits. This could lead to more liquid markets for illiquid assets, allowing for fractional ownership and easier transfer of value. Debunking myths and misconceptions. The NFT space has certainly faced its share of hype, speculation, and criticism. Environmental concerns. The energy consumption of proof-of-work blockchains, like Ethereum was before its transition to proof-of-stake, was a valid concern. However, with Ethereum's merge to proof-of-stake in 2022, its energy consumption was drastically reduced, making NFT creation and trading significantly more energy efficient. Volatility and speculation. Many NFTs have seen massive price swings, leading to accusations of speculative bubbles. While speculation is undoubtedly a factor, it's crucial to distinguish between purely speculative assets and NFTs that offer genuine utility, community value, or artistic merit. I can just write, click, and save the image. This is perhaps the most common misconception. Yes, you can save a copy of the digital file, but you don't own the NFT, just like you can take a picture of a rare baseball card but don't own the card itself. The NFT is the provable, verifiable ownership record on the blockchain. NFTs, powered by smart contracts, represent a paradigm shift in how we define, verify, and transfer ownership in a digital world. They lay the groundwork for a future where digital assets are no longer ephemeral, but can be truly owned, traded, and integrated into complex, decentralized economies. Just as smart contracts empower individuals to own digital assets, they also enable groups of people to make collective decisions and govern themselves in novel ways. Which brings us to our next major application: decentralized autonomous organizations. Governing together, decentralized autonomous organizations, DAOs. So far, we've explored how smart contracts enable individuals to transact directly, DeFi, and own unique digital assets, NFTs. Now, let's consider how smart contracts can transform the very structure of organizations and decision-making. This takes us into the realm of decentralized autonomous organizations, or DAOs. The promise of decentralized governance. Traditional organizations, from corporations to nonprofits, are typically hierarchical. Decisions flow down from a CEO, a board of directors, or a management team. This model has proven effective for centuries, but it also has its drawbacks: opacity, slow decision-making, potential for corruption, and a single point of failure. Members of the organization, employees, shareholders, community members, often have little direct say in its operations or future. DAOs aim to replace this centralized authority with transparent, community-driven decision-making, managed and enforced by smart contracts. The core philosophy is simple yet revolutionary: to create organizations that are governed by code and community consensus, rather than by a single person or a small group of executives. A DAO is essentially an organization whose rules are encoded as a transparent computer program, a smart contract, controlled by its members and not influenced by a central government or traditional entity. Its treasury is often managed directly by the smart contract, accessible only through collective voting. What is a DAO? Structure and mechanics. At its heart, a DAO functions on a few key principles enabled by smart contracts. Rules encoded in code. The foundational rules of a DAO are written into one or more smart contracts. These rules dictate how decisions are made, how funds are managed, and how new members are onboarded. Because these rules are on the blockchain, they are transparent and immutable. Membership and governance tokens. Membership in a DAO is often, though not exclusively, based on holding a specific type of cryptocurrency called a governance token. These tokens often bestow voting power, with more tokens typically granting more voting weight. Proposals and voting. Any member meeting certain criteria, e.g., holding a minimum number of governance tokens, can typically submit a proposal for the DAO to consider. This proposal could be anything from allocating funds for a new project, changing a protocol parameter, or even hiring new contributors. Proposal details are transparently displayed, and token holders then vote on these proposals directly on the blockchain. Automated execution. This is where the autonomous part comes in. Once a proposal passes with the required threshold of votes, the underlying smart contract automatically executes the outcome. For example, if a proposal to disperse funds to a new development project passes, the smart contract automatically releases the specified amount from the DAO's treasury to the relevant address, without any human needing to manually authorize the transfer. This structure creates truly transparent and community-owned organizations, where every decision and financial transaction is recorded on the blockchain for anyone to inspect. The DAO exploit. A cautionary tale. While the concept of DAOs promises a brighter future, it's crucial to acknowledge the early, painful lessons learned. The most significant event in DAO history is arguably the DAO exploit of 2016. Background: in 2016, the DAO, often referred to with a capital T to distinguish it from the general concept of DAOs, was launched as a pioneering decentralized venture capital fund. It raised a staggering sum, over $150 million worth of Ether, which at the time was roughly 15% of all ETH in circulation. The idea was that token holders would vote on which projects to invest in, and the return profits would be distributed amongst them. The hack: despite being audited by security experts, a subtle vulnerability, or bug, in the DAO's smart contract code was exploited. An attacker found a way to repeatedly withdraw Ether from the DAO's funds before the transaction could be fully processed, effectively draining a significant portion of its treasury into a separate child DAO under their control. Consequences: the Ethereum fork. The exploit triggered a major crisis within the nascent Ethereum community. The code is law principle meant that the funds, according to the contract's code, were legitimately transferred. However, many in the community saw this as theft and wanted to undo it. This led to a contentious debate and, ultimately, a hard fork of the Ethereum blockchain. The majority voted to implement a software update that effectively rewound the chain, restoring the stolen funds to their rightful owners. The original unforked chain continued as Ethereum Classic, ETC, while the new, restored chain became the Ethereum ETH we know today. Lesson learned. The DAO exploit stands as a stark reminder of the immense stakes involved with smart contracts. Immutability means that once a contract is deployed, any flaws or vulnerabilities are permanent and can be devastating. It underscored the absolute criticality of rigorous smart contract auditing, painstaking development, and the need for established legal or governance frameworks to handle unforeseen circumstances. Modern DAOs, diverse applications. Despite that early setback, the DAO concept has matured, and thousands of DAOs now exist, governing various aspects of the decentralized world. DeFi protocol governance. Many leading DeFi projects, such as Uniswap, Aave, and Compound, are governed by DAOs. Token holders vote on critical protocol parameters, fee structures, and future development initiatives. This ensures that the financial infrastructure remains community-owned and user-centric. Investment DAOs. Building on the original vision, modern investment DAOs pool capital from members to invest in promising Web3 projects, NFTs, or other assets collectively. Projects like Flamingo.io or Pleaser DAO have collectively purchased high-value NFTs and digital art. Constitution.io even famously raised over $40 million in a bid to buy a rare copy of the U.S. Constitution, though they ultimately lost the auction. Grant-giving DAOs. These DAOs allocate funds to support new projects, research, or public goods within the blockchain ecosystem, fostering growth and innovation in a decentralized manner. Social DAOs and communities. Many online communities are adopting DAO structures to manage shared resources, organize events, and make collective decisions. They range from small interest groups to large metaverses. Gaming guilds, plate-to-earn games, where players earn cryptocurrency or NFTs by playing, have spawned gaming DAOs like Yield Guild Games, YGG. These DAOs acquire valuable in-game assets, like expensive NFT characters or virtual land, and then lend them to players in developing countries, allowing them to earn income. Challenges and future of DAOs. While empowering, DAOs face significant challenges. Participation and engagement. Just like traditional democracies, voter apathy can be an issue. Ensuring widespread and informed participation in governance can be difficult. Legal uncertainty. The legal status of DAOs is still largely undefined in many jurisdictions. Are they companies, partnerships, or something entirely new? This creates challenges for legal liability, taxation, and regulatory compliance. Scalability of decision-making. While efficient for simple yes/no votes, complex technical or strategic decisions can be cumbersome or politicized in a fully decentralized voting process. Security risks. Despite advancements, smart contract bugs remain a risk. Furthermore, governance attacks, where malicious actors acquire enough tokens to control a DAO, are also a theoretical concern. Despite these hurdles, DAOs represent a powerful experiment in new forms of human coordination and organization. They embody a shift towards more transparent, community-owned, and democratized structures. Just as smart contracts empower new forms of ownership and governance, they also face significant challenges and considerations that must be understood to navigate this evolving landscape responsibly. The road ahead. Challenges and considerations for smart contracts. We've explored the revolutionary potential of smart contracts, from enabling decentralized finance to powering digital ownership and new forms of governance. However, like any nascent technology, smart contracts and the broader blockchain ecosystem face significant hurdles. Understanding these challenges is crucial for a balanced perspective and for appreciating the ongoing efforts to mature this transformative technology. Security vulnerabilities. Code as law can be a double-edged sword. The immutability of smart contracts, which is a core feature enabling trust, is also their greatest vulnerability. Once deployed, a smart contract's code is set in stone. If there's a bug, an error, or a flaw in the code, it cannot be easily fixed or updated without significant effort, and sometimes not at all, leading to potentially catastrophic losses. As the DAO exploit painfully demonstrated, a seemingly minor coding error can have real-world, irreversible financial consequences. Common types of vulnerabilities include reentrancy attacks, where an attacker can repeatedly call a function to drain funds before the original transaction is finalized, as seen in the DAO hack. Integer overflows underflows, where mathematical operations produce incorrect results because a number exceeds its maximum or falls below its minimum value. Access control issues, flaws that allow unauthorized users to perform privileged actions. Because of this, code is law nature. Simply writing good enough code isn't enough. It must be near perfect when deployed. This has given rise to a specialized industry of smart contract security audits. Expert firms meticulously review contract code for vulnerabilities before deployment. However, even audited contracts can sometimes contain undiscovered flaws, making meticulous development and continuous vigilance paramount. The responsibility on developers building these systems is immense. Scalability, the traffic jam on the blockchain. Ethereum, the leading platform for smart contracts, has faced significant scalability challenges. As the network becomes more popular and more dApps are built on it, the demand for transaction space increases. This can lead to high gas fees. When the network is congested, users have to pay higher gas fees, transaction costs, to ensure their transactions are processed quickly. This makes interacting with smart contracts expensive especially for smaller transactions, limiting accessibility and adoption. Slow transaction times. During peak demand, transactions can take minutes or even hours to be confirmed, leading to a poor user experience. This challenge is often referred to as the blockchain trilemma, which posits that a blockchain can typically only optimize for 2 out of 3 desirable properties: decentralization, security, and scalability. Ethereum initially prioritized decentralization and security, often at the expense of scalability. However, significant efforts are underway to address this. Ethereum's shift to proof-of-stake, the merge. While primarily aimed at improving energy efficiency, the successful transition of Ethereum to proof-of-stake, PoS, was a foundational step paving the way for future scalability upgrades. Layer 2 solutions. These are separate protocols built on top of the main Ethereum blockchain, Layer 1. They process transactions off-chain, bundling many transactions into a single, compact transaction that is then settled on the main chain. Examples include optimistic rollups, e.g., Optimism, Arbitrum, and ZK rollups, e.g., ZK Sync, Starknet. By offloading computation, Layer 2s drastically reduce transaction costs and increase throughput while still leveraging Ethereum's security. Sharding, future Ethereum upgrades. In the long term, Ethereum plans to implement sharding, which would involve dividing the blockchain into smaller parallel chains called shards. Each shard would process its own transactions simultaneously, dramatically increasing the network's capacity. Legal and regulatory uncertainty. The decentralized and global nature of smart contracts poses significant challenges for existing legal and regulatory frameworks. Jurisdictional headaches. Who governs a smart contract if it's deployed on a global network and users interact with it from different countries? This makes enforcement of traditional laws complex and unclear. Legal enforceability. While smart contracts are self-enforcing in code, their legal standing in a court of law is often ambiguous. Are they legally binding contracts? Can they replace traditional contracts? In many cases, a legal wrapper is still advised, where a traditional legal agreement references and runs alongside a smart contract, providing an avenue for traditional dispute resolution if the code fails or is disputed. Compliance. Issues like anti-money laundering, AML, and Know Your Customer, KYC, regulations become problematic for truly decentralized applications that aim for permissionless access. Regulators are grappling with how to impose compliance requirements on entities that may not have a central managing body, like DAOs. Taxation. How are transactions involving smart contracts, DeFi yields, or NFT sales taxed? Tax authorities worldwide are still developing clear guidelines, leading to uncertainty for users and developers. Usability and user experience, UX. Despite the technological advancements, interacting with smart contracts and the broader Web3 ecosystem can still be daunting for the average user. Complexity. Concepts like gas fees, transaction confirmations, public-private keys, and seed phrases are foreign to most internet users. Setting up a wallet, securing seed phrases, and managing multiple networks can be significant hurdles. Loss of funds. If a user loses their private key or seed phrase, their funds are irretrievably lost. Sending funds to the wrong address means they are gone forever. This lack of a reset password or undo button, while a feature for security and decentralization, presents a massive barrier to mass adoption. Steep learning curve. Onboarding new users to dApps often requires them to understand a completely new set of mental models compared to traditional websites or apps. This steep learning curve is a major impediment to broader adoption. Significant work is being done by developers to improve user interfaces, abstract away cryptographic complexities, and create more intuitive onboarding experiences. Environmental concerns, renewed discussion. While Ethereum's shift to proof-of-stake drastically reduced its energy consumption by an estimated 99.95%, the blockchain industry as a whole still faces misconceptions and scrutiny regarding its environmental footprint. Bitcoin's continued use of proof-of-work means some blockchain activities remain energy-intensive. As smart contracts expand into new domains, ensuring the underlying infrastructure is sustainable will remain a critical consideration. These challenges are not insurmountable, and the bright minds in the blockchain space are actively working to address them. The journey from niche technology to mainstream utility is rarely smooth. Understanding these hurdles helps us appreciate the complexity of the future that smart contracts are building. Despite them, the ingenuity driving development in the smart contract space promises a future with profound real-world impact. Real-world impact and future possibilities. Having navigated the mechanics of smart contracts and explored their current applications in DeFi, NFTs, and DAOs, it's clear that this technology isn't just about cryptocurrencies. Smart contracts are a fundamental building block for a new internet, often called Web3, and are poised to reshape countless industries. Let's look beyond the headlines to see some of the broader real-world impacts and fascinating future possibilities that smart contracts could unlock. Supply chain management and traceability. One of the most promising applications of smart contracts is in supply chain management. Traditional supply chains are often opaque, fragmented, and vulnerable to fraud or inefficiencies. It can be incredibly difficult to track a product from its raw material origin to the consumer's hands, leading to issues with authenticity, ethical sourcing, and delays. The solution: smart contracts can create a transparent and immutable record of every step a product takes. Each time a product or its components changes hands, is processed, or receives a certification, that event can be recorded on a blockchain via a smart contract. How it works: imagine a smart contract that dictates that a payment to a coffee farmer is released only when the coffee beans arrive at the roasting plant and are verified as fair trade. Or a contract that tracks a pharmaceutical product, ensuring its temperature was maintained throughout transport, triggering an alert if conditions deviate. Impact: this enables unprecedented traceability, combating counterfeiting, ensuring ethical sourcing, reducing waste, and automating payments based on verified milestones. Consumers could, for example, scan a QR code on a product and instantly see its entire journey, verified by blockchain entries. Identity management, self-sovereign identity, SSI. In today's digital world, our identities are fragmented and controlled by various centralized entities, governments, passports, banks, KYC, social media companies, login credentials. This often leads to privacy concerns and makes it difficult to manage our own data. Self-sovereign identity, SSI, enabled by smart contracts, offers a revolutionary alternative. The concept: SSI empowers individuals to own and control their digital identity. Instead of relying on central authorities to verify who you are, you would hold cryptographic verifiable credentials in your blockchain wallet. How smart contracts play a role. Smart contracts can confirm the issuance of these credentials by trusted parties, e.g., a university issuing a degree, a government issuing a driver's license. You can then selectively disclose parts of your identity to different services without revealing everything. For example, a smart contract could verify that you are over 21 without revealing your exact birth date or full name. Impact: greater privacy, enhanced security against data breaches, and more control over your personal information. It fundamentally shifts power from institutions to individuals, allowing for a more equitable and secure digital existence. Digital voting and governance beyond DAOs. Building on the transparency and immutability of blockchain, smart contracts hold immense potential for revolutionizing voting systems, both in government elections and within large organizations. The potential: a voting system based on smart contracts could be tamper-proof, with every vote recorded transparently and immutably on the blockchain, yet anonymized to protect individual privacy. This could eliminate concerns about election fraud, central tabulation errors, or lost ballots. Challenges: implementing such a system on a national scale involves complex challenges like identity verification, ensuring one person, one vote, voter anonymity versus public verifiability, and scalability to handle millions of votes without congestion. However, for smaller-scale governance within organizations or local communities, blockchain-based voting is already being explored. Real estate and physical asset tokenization. Tokenization refers to the process of representing ownership of real-world assets as digital tokens on a blockchain, governed by smart contracts. This concept could revolutionize industries dealing with traditionally illiquid or hard-to-transfer assets. How it works. A smart contract would encode the ownership terms of an asset, like a fraction of a commercial building, a piece of art, or even a barrel of oil. These security tokens can then be bought, sold, and traded digitally. Benefits. Fractional ownership allows multiple investors to collectively own a high-value asset, lowering barriers to entry. Imagine owning a small percentage of an iconic skyscraper or a Picasso painting. Increased liquidity. Physical assets can be illiquid. Finding buyers can be slow. Tokenization allows for near-instant transfer of ownership on a blockchain. Reduced intermediaries. Streamlines legal and financial processes, potentially reducing fees and delays associated with brokers, lawyers, and traditional registrars. Current progress. While still in early stages due to regulatory complexities, projects are emerging that tokenize real estate, artwork, and even private equity shares using smart contracts. Philanthropy and social impact. Smart contracts can bring unprecedented transparency and efficiency to charitable giving and social impact initiatives. Transparency. Donors could track their contributions through the blockchain, ensuring funds reach their intended recipients and are used for the stated purpose. A smart contract could release funds to a specific project milestone upon verified completion. Automated distribution. For disaster relief, smart contracts could automatically distribute funds to verified victims based on specific conditions, e.g., proof of residence in a disaster zone. Impact. This enhances trust, reduces corruption, and ensures greater accountability in the nonprofit sector. Interoperability and the multi-chain future. Currently, many blockchains operate in silos. An asset on Ethereum might not easily move to a different blockchain like Solana or Avalanche. However, the future vision is one of interoperability, where different blockchains and their smart contracts can communicate and interact seamlessly. Bridges. Smart contracts play a crucial role in bridges that allow assets and information to move securely between different chains. Implication. This would create a more interconnected, fluid, and expansive decentralized ecosystem, where dApps can leverage the strengths of multiple blockchains, leading to even more powerful and versatile applications. As we conclude our exploration, it's clear that smart contracts are more than just a technological curiosity. They are a fundamental shift with profound implications for how we organize, transact, and interact in the digital age. They are laying the groundwork for a future that is more transparent, efficient, and potentially more equitable, reshaping the very fabric of our digital and, increasingly, physical lives. Conclusion. Building the future, smart contract by smart contract. We have embarked on a journey to demystify smart contracts, unraveling their technological underpinnings and exploring their transformative power. From their conceptual origins to their tangible impact across various industries, we've seen how these ingenious pieces of code are reshaping our digital landscape. Recapping the journey. From concept to impact, let's briefly recap the ground we've covered. We began by understanding what smart contracts are. Self-executing, tamper-proof digital agreements that automate if this then that conditions, much like a trusted vending machine. Their key properties, immutability, transparency, and determinism, lay the groundwork for a trustless system. We then delved into Ethereum, the leading blockchain platform that serves as the world computer for smart contracts. Thanks to its robust Ethereum virtual machine, EVM, and decentralized network of validators, we dissected the anatomy of a smart contract, revealing how functions and state variables govern their behavior, how oracles connect them to the real world, and how decentralized applications, dApps, provide user-friendly interfaces. Our exploration continued into the revolutionary applications. Decentralized finance, DeFi, where smart contracts are rebuilding financial services anew, enabling peer-to-peer lending, borrowing, and trading without traditional intermediaries. Non-fungible tokens, NFTs, which harness smart contracts to establish unique, verifiable digital ownership for art, collectibles, gaming assets, and much more, ushering in a new era of digital scarcity. Decentralized Autonomous Organizations, DAOs, showcasing how smart contracts facilitate transparent, community-driven governance, allowing groups to make collective decisions and manage resources without central authority. Finally, we face the challenges and considerations on the road ahead: security vulnerabilities, scalability bottlenecks, legal uncertainties, and user experience hurdles. Acknowledging that this powerful technology is still evolving and requires meticulous attention. Despite these challenges, we look to the future, envisioning the profound real-world impact and future possibilities across diverse sectors, including transparent supply chains, self-sovereign identity, tokenization of physical assets, and even new forms of philanthropy and interchain communication. Decentralization, as a guiding principle, at the heart of smart contracts and the broader blockchain movement, is a powerful philosophical shift. Decentralization. It's about moving away from relying on powerful central authorities, whether banks, governments, or tech giants, and toward systems where trust is distributed across a network, verifiable through code, and decisions are made transparently by a community. Smart contracts are the very mechanism through which this ideal is actualized. They encapsulate rules and execute actions without bias, freeing us from reliance on fallible human intermediaries. This empowers individuals and communities, facilitating novel forms of collaboration and value exchange. Empowering the user. Knowledge is power. The world of decentralized technologies is rapidly expanding, and with it comes immense opportunity. However, it also demands a new level of personal responsibility. In a trustless system built on code, there are no customer service lines to call if you lose your private key, no bank to reverse a transaction sent to the wrong address. Your security and autonomy are entirely in your hands. This is why understanding the fundamentals, as we've done throughout this book, is crucial. Knowledge empowers you to navigate this space safely, make informed decisions, and critically evaluate the projects and opportunities that emerge. The unwritten chapters. What comes next? It's important to remember that smart contract technology is still in its infancy. The innovations we've seen so far are merely the tip of the iceberg. The full potential of these digital agreements is yet to be realized, and the applications being developed right now are pushing boundaries we can barely comprehend. We are witnessing the very early stages of a new internet economy, one built on programmable trust and verifiable ownership. The challenges we discussed are real, but dedicated researchers, developers, and entrepreneurs worldwide are tirelessly working on solutions, constantly iterating and improving the underlying infrastructure to make it more scalable, secure, and user-friendly. Practical steps for the curious reader. If this book has sparked your curiosity and you wish to delve deeper, here are some practical first steps. Set up a non-custodial wallet. This is your gateway to interacting with Ethereum. Wallets like MetaMask, a browser extension, are a common starting point. Start with a small amount of ETH. Explore a DApp. Visit a simple decentralized application, perhaps a small NFT marketplace or a DeFi dashboard, and observe how your wallet connects to it and interacts with smart contracts. Learn more about gas fees. Experiment with the network when gas fees are low to understand how they work without breaking the bank. Stay informed. Follow reputable news sources, educational platforms, and community discussions. Always exercise caution and perform your own research before engaging with new protocols or assets. Resources for further reading and a glossary of terms are provided at the end of this book. Final thought: smart contracts are far more than just a tech trend. They are a fundamental shift in how we can design and enforce agreements in the digital domain. They offer a future where transparency, automation, and verifiable trust are the default, rather than the exception. By demystifying this powerful technology, we hope to have equipped you with the foundational understanding to not only comprehend this ongoing revolution, but perhaps to even participate in building its next chapter, one smart contract at a time.